In our previous video, we discussed one of the properties of an image formed by a concave mirror. This property states that a concave mirror forms both real and virtual images. It depends on the distance between the object and the mirror. If the object is too close to the mirror, a virtual image will be formed, and if it's further away, a real image will be formed. Okay, so as I said, the formation of an image depends on the distance between the object and the mirror. In fact, not only this property, every property of the image formed in a concave mirror depends on how far the object is kept from the mirror. First of all, tell me what properties can an image in a concave mirror have? We have already studied the properties of images in a plane mirror. The nature of the image, size of the image, and position of the image are some of the properties that an image in a plane mirror can have. Similarly, for an image formed in a concave mirror, its nature, its size relative to the object, and its position in space are the three properties that we're interested in. For now, we'll only talk about the size of the image and the nature of the image. As I said, all the properties of the image formed in a concave mirror vary with the object's distance from the mirror. So if the distance between the object and the mirror change, the size and the nature of the image change as well. Let us now try to find out how this change comes about. So without boring you any further, I will make a table on the right with 3 columns. The first column will tell us where the object is positioned in front of the mirror. The second one will tell us the size of the image. And the third will tell us the nature of the image, that is, whether the image is virtual or real. So this is our concave mirror. We all know by now that a concave mirror has its reflecting surface curved inwards. So let's try and find out the properties of an image formed by a concave mirror. I will show you 2 views of the mirror, the front view and the side view. The side view is just to show the different positions where the object is kept, as it's difficult to do that using the front view. The 3 entries in the first column of the table are these ones. The first and the last entries are the positions of the object when it's too close to the mirror and when it's very far away from the mirror. The middle one is the position of the object in between the 2 extreme positions. The properties of the image that we will discuss are only for these 3 different positions of the object. Now let's bring in our object. Assume that initially the object is kept very close to the mirror. This is how its image will appear. Can you tell me its properties? What is the size of the image? We see that the reflection in the concave mirror, that is the image, is bigger in size. The word we use is enlarged. What about the nature of the image? Is it real or virtual? Yes, it's a virtual image. Why? Because if it was a real image, then it would have been upside down. We know from our previous videos that real images are always upside down. Since this image is upright or erect, it is a virtual image. So for this position of the object, the nature of the image is virtual and erect. Okay, now let's move this object away from the mirror and see how the dimensions and the nature of the image vary relative to the object. You will find that as we move this object away, its image gets even bigger. And at some point, the image will be huge in size. This position of the object is not some random position. It's been given a name. This position is called focal point. Whenever any object is at focal point of a concave mirror, its image will be highly enlarged. This is always true for any image in a concave mirror. You are going to learn more about this focal point in your higher grades. However, let's keep moving our object further away from the mirror. You will find that the size of the image keeps on reducing. However, compared to the size of the object, the image is still bigger. But you must have noticed one interesting thing. Yes, now the image is upside down. This means that this is a real image. Here is one interesting fact. Whenever the object is kept beyond the focal point of a concave mirror, its image will always be a real image. What will happen if we move the object further away from the mirror? Let's find out. As you keep moving further away, you will find that at some point, both the image and the object will be of the same size. And the image will be real and inverted. And if you move the object further behind this position, the image will be a real image. However, its size is now lesser compared to the object. So what can we conclude from this? We can say that when the object is in between the two extreme positions, then the image can either be enlarged or diminished or of the same size. What about the nature of the image? Yes, the nature of the image is real and inverted in all cases. What if our object is very far away from the mirror? Then the image will be a really small image. This will almost be a point-sized image. The nature of the image will be the same, that is, real and inverted. So these are the properties of images formed in a concave mirror. Let's quickly review these properties. If the object is close to the concave mirror, then its image is bigger in size compared to the object and it's a virtual image. As I keep moving the object away from the mirror, the size of the image keeps on increasing until at one particular position where the image is huge in size. From there on, the image will be real and inverted, but its size keeps on reducing. And when the object is very far away from the mirror, the image is highly diminished and point-sized. But wait a moment. We are not done yet. There is one more spherical mirror remaining, and we will discuss the properties of the images formed in it in our next lesson.